Hi friends, in this video we are going to learn about what is meant by GAUSS-Jacobi iterative method. So here usually this method is used for large system of equation, but here for your sake of understanding, so I will explain this method for 3 equation and 3 unknown. So after that we can generalize for any m and n. So here 3 equations a11 x1 plus a12 x2 plus a13 x3 equal to b1. In this way, second equation, this is my third equation, a31 x1 plus a32 x2 plus a33 x3 equal to b3. Now all of you know the coefficient matrix of this system is a11, a12, a13. That is my first row, and second row is a21, a22 and a22, a23, and third row is a31, a32 and a33. Now we should be, so here the first condition for the Gauss-Jacobi iteration method is that system should be diagonally dominant. What is meant by diagonally dominant? In the coefficient matrix, the diagonal entries are a11, a22 and a33. So in the coefficient matrix. Now here the diagonal entry a11, the absolute value of a11 should be strictly greater than the absolute value of the remaining element in that row. That is here a11 should be strictly greater than a12 plus a13 absolute value. In the same way, now come to this equation. This is the diagonal entry of second row in my coefficient matrix. A22 strictly greater than A21 plus A23. Now come to the third here. A33 mod of absolute value of A33 strictly greater than A31 plus A32. Now this is my first step. Now write the given system, this system in terms of x1 corresponding to the diagonal entry A11. So here I will take here a11 x1 equal to b1 times I will take from here to here. I will take this much part from right hand side. So here after that I will divide a11. a11 is equal to b1 minus a12 x2 minus a13 x3. In the same way you can write here this equation in terms of x2 corresponding to the diagonal entry a22. So here you can write x2 as 1 by a22 equal to, you can take here this part and this part to the right hand side. So here b2 minus this a21 x1 minus here a23 x3. Now you can take right in terms of x3 here corresponding to the equation 3. Here a33 x3 is equal to, here take this much part to the right hand side. So b3 equal 1 by a33 minus 1 by a33 into b3 minus a31 x1 minus a32 x2 a32 x2 into x3. Now the third step is here take the initial guess x1 at 0, x2 at 0, x3 at 0 as 0, 0, 0. Now come to the here, find the next iteration using the previous iteration values as x1 at k plus 1 equal to, so here x1 at k plus 1 equal to 1 by a11 minus here b1 minus a12 x2 at k, a13 x3 at k. Means here x1 at 1. For example, if I put k is equal to 0, here this is my x1 at 0, x2 at 0, x3 at 0 is given. That is my 0th iteration, say 0, 0, 0. Now here x1 at 1 means 1, that is k is 0, x1 at 1. Here 1 by a1 1, b1 minus a12 x2 at 0, x13 x3 at 0. In the same way x2 at 1 means 1 by a22 b2 minus a21 x1 at 0 and x3 at 0. So in this way you can calculate x1 at 1, x2 at 1, x3 at 0. So when you are putting k equal to 0, now put k equal to 2. So in this iteration, if you put k equal to 1, now you will get x1 at 1, x2 at 1 and x3 at 1. Now in the second iteration x2, x1 at 2, x2 at 2 and x3 at 2, you have to use x1 at 1, x2 at 1 and x3 at 1. In this way you can go. So repeat this step until the convergence, continue until successive values are sufficient close. That is this xi k plus 1 minus xi is less than epsilon. Here epsilon is any real number. You can take epsilon as 10 to the power minus 3 or 10 to the power minus 4. That is very small. So thank you.